This is for year 11 methods. We're going to look at question 3. We're looking at graphs where we have to sketch it, sketch two graphs first because we've got a left and right shift. So the first step to sketching these graphs is to look at what left-right transformation we've got. We can see that we have assigned to x minus pi over 3, which means we're shifting the graph pi over 3 to the right. So the key step to drawing these type of graphs is to draw the base case first, which is sine of 2x. We know the amplitude of this graph is 1, and the period is 2 pi and n, which is 2 pi over 2, which equals pi. Now, how did I arrive at the, conclusion that we needed to do it over 12s? Is because the period of the graph is pi. If I divide that into quarters, because I want to get my 4 points to draw the shape of the graph, then I need quarters, and I'm shifting the graph pi over 3 to the right, which means that I need a number that's compatible with 3 and 4, which means 12s is a naturally good selection. So if I were to draw the graph very roughly, or more precisely, if I were to draw the graph, then I need to divide it into 12. So my amplitude's 1. That's pretty easy to do. So 1 and negative 1. And I'm going to divide my graph into 12. So 12 pi over 12 and 24 pi over 12. And if I go 6 pi over 12 and 18 pi over 12, that's 24 pi over 12, I can then divide this in half and then put 2 lines in each half. So divide that in half, 2 lines, 2 lines, divide this in half, 2 lines, 2 lines, divide this half, 2 lines, 2 lines, and if I count, I should get 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, perfect. We can actually get our shape correctly. Now, I want to go a bit over here, negative 6 pi over 12. Divide this into halves and then divide those halves into 2. So I can now proceed to draw my basic graph. It's a positive sine graph, so it's going to go median, max, median, min, and then median. Median then goes to max, goes to median, min, mean. Draw our basic shape. Okay. And I can draw a basic shape here because it goes here, then there. Now, we know that our graph has been shifted pi over 3 to the right. I need to get pi over 3 in terms of 12, so that's 4 pi over 12. Now, let's proceed to draw our graph that's been shifted. So the points would be shifted 4, 1, 2, 3, 4 here. 1, 2, 3, 4 here. 1, 2, 3, 4 here. 1, 2, 3, 4. 1, 2, 3, 4 here. 1, 2, 3, 4 here. 1, 2, 3, 4 here. Then we go 1, 2, 3, 4 here. 1, 2, 3, 4 here. We'll create another point here. And if I go back to the negative region, 1, 2, 3, 4 here, and 1, 2, 3, 4 here. Okay, so if I were to draw the graph, it looks something like this. And can you see that I stop somewhere here? I don't go all the way, so I stop somewhere here, and with this part, I don't go all the way, I stop at around here. Okay, So now what we do is we need to calculate our y-intercept. We need to calculate what that point is. So f of 0 equals sine 2 negative pi over 3. That's the same as sine negative 2 pi over 3. Now, negative 2 pi over 3 is actually in the third quadrant because it's almost negative pi, but pi over 3 less, or pi over 3 from negative pi. That's equivalent to, in the third quadrant, sine is negative sine pi over 3. So it's negative sine pi over 3, so it's negative 3 root 3 on 2. Similarly, f of 2 pi would give me the endpoint at 2 pi. So it's sine 2 of 2 pi minus pi over 3. So equals sine 2 negative 10, not negative, 5 pi over 3. So equals sine 10 pi over 3. Now I can get rid of 6 pi over 3 because that's one revolution around a circle. So we're left with 4 pi over 3. Again, it's in the third quadrant. It's exactly the same value. So it's equivalent to negative pi over 3, negative root 3 over 2. So I can label that endpoint negative root 3 over 2, or 2 pi negative root 3 over 2. Okay. 2 pi negative root 3 over 2. To get the x-intercepts is actually quite easy. I don't know what the points are. 1, 2, 3, 4. 4 on 12 is the same as a fraction. That's pi over 3. Okay. 4 and 12 simplifies to pi over 3. 6, 7, 8, 9, 10. 10 pi over 12 is the same as 6 pi over, no, 5 pi over 6. 5 pi over 6. Next point is 13, 14, 15, 16. 16 pi over 12 is the same as 4 pi over 3. And the next one, 18, 19, 20, 21, 22. 22 pi over 12 is the same as 11 pi over 6. Okay, so sometimes you don't even need to solve the equation because our scale is good. We can literally count and simplify the fraction to get what our point is. So the last step is to label like which graph's which. So that equals y equals 2 sine sine 2 x minus pi over 3, and we're done. Hopefully this helps you get an understanding of how you approach these subgraphs. They're not impossible. They are long, but they're totally